Hi there! How are you? Now consider these two given functions here, f of x being x squared minus 4 and g of x to be 2x minus 4. And let us try to determine their sum and difference. Let's start with f plus g of x. When you have this expression, this means we simply add the terms or the expressions corresponding with f of x and g of x. And whenever you do something like this, of course, it's okay to write immediately f of x being x squared minus 4. But whenever you add or subtract or operate generally functions, please do not forget to use parentheses for the next function. Now, it may not hurt the result of this operation here, but for most cases, especially dealing with subtraction and for other cases where there are numerical coefficients with negative signs before it, you have to change the signs of whatever would be the expression in this grouping symbol. Again, it will not hurt this time, but let's try to have parentheses, and then you will have here 2x minus 4. Now that before that grouping symbol is addition, you may just simply remove the grouping symbol without any problem. The 2x will still be 2x, and the 4 or minus 4 will still be minus 4. In short, the sum of f and g of x, or f plus g of x, is simply the simplified form of this. You have x squared plus 2x, and we have minus 4, that means minus 8. This is now the result for the sum of the two functions. Now, if ever you are asked to do this as well, you have g of f of x. You will actually have the same result. This is because addition is commutative. So if you're going to try solving for this, you will still end up with the result x squared plus 2x minus 8. However, this is not true for subtraction. So if we're going to have here f minus g of x, this result would be different when we write g minus f of x. Because then again, subtraction is not commutative. Just like 2 minus 1 being 1, but 1 minus 2 is negative 1. Just for this case, let's subtract these two functions. So we have x squared minus 4. And this is where the importance of our parentheses would be exemplified. So you will have here 2x minus 4. Because if you don't have this grouping symbol, you might come across with minus 4 still here. But when you have a negative expression before a grouping symbol, this is what will happen. You have x squared minus 4. The positive 2x inside the grouping symbol becomes minus 2x. And the minus 4 becomes plus 4. This is due to the distribution of the negative sign by multiplication. Negative times positive, negative. Negative times negative, positive. This would mean that f minus g of x will result to the expression equal to x squared minus 2x. And since you have here minus 4 plus 4, that's 0, you end up with a binomial expression with this. As mentioned, this is different when you try to solve for g minus f of x. Because this would mean you will have 2x minus 4 minus the grouping symbol of x squared minus 4. And when you have something like this, that's 2x, still minus 4. Now your x squared becomes minus x squared. Just for this expression alone, notice the difference between this result and the result earlier. Earlier, it was positive x squared. Now, you will have negative x squared here. And of course, you will have here plus 4. So your final answer here for g minus f of x, or let me write it here, g minus f of x would be negative x squared, that's x, then positive 2x. And of course, negative 4 plus 4 is still 0. Notice the two results, they are not the same. So these are now the result when we add or subtract functions. That's all for today. You're dismissed. And please do not forget to subscribe now.